Welcome back. Lesson 2, circular slide rules. Part 1 is the basics, where we cover off some of the primary components that we have to get to grips with before we start getting really funky. Hopefully everyone has gone through all the lesson 1 stuff and is happy with it. It's critical because there's about 40% worth of your final pass grade in those questions. Some of the things that we have to understand about the circular slide rule is that when you go into your exam, you're going to have no calculator. You're just going to get a pen and paper and your E6B or whatever circular slide rule you're using. So it's important that we cover off the basics in this component so that we can just get to grips with some of the primary conversions that you're going to have to do before we start getting into the wind side and everything else. So we're just going to do a basic quick walkthrough of the E6B, the front, the back, and the basic calculations. Let's kick it off. So as you can see from the picture, my E6B has, out of frustration, got a little bit damaged. The frustration comes with the fact that it's not the most precise instrument in the world. This is known by the examiners, and the exam questions are geared in a way that the answers have got a tolerance. Most of the time, from a PPL or a CPL point of view, we're going to be using the electronic versions of these anyway, but until that becomes a standard, we still have to use this wonderful piece of kit that dates back to World War II. So it's got two sides which are used to perform different tasks. The back side is used for the calculation of trigonometry, wind, and we'll get into that on part 2 of lesson 2. The front side is a very clever piece of kit in the fact that you can do some really interesting calculations. So the basic parts. One is the plotter, and again we'll get to that in part 2. On the opposite side of the plotter, there are some helpful calculations or calculating tips that you can use. This will come in very handy when you're in the exam, when you're trying to recall how to do various bits and pieces. Number 2 is the rotating or the circular part of that slide rule. It's also at the bottom. It's got a temperature conversion chart. If you do take the time to read the instruction book, the little clippy thing on the side is never mentioned, and I can only presume it's to thread a piece of string round or to wear it as an ornament. But that's really the basic side of the front. On the reverse is an area for determining triangular velocities and areas where you can mark and calculate from there. The rotating dial and the surface. It is pencil friendly. I generally use a fine point black marker, which it's a whiteboard marker, so it's non-permanent, and that gives us a much more precise. But if you're going to use pencil, make sure it's sharp, but also make sure it's not a hard pencil, because damaging that it's potentially useless after you've used it a couple of times. So the scales. So before we actually get into some of the problems, we've got to really identify what these scales and the numbers on the inner, the outer rotations are. So first we'll define the scales and the pointers, and then I'll show you how to put them into action. So on the front side of the E6B, and it helps if you've got it in front of you, it's essentially a circular slide rule with we say 3 separate scales. There's actually more when you start looking at the TAS areas as well. But there's 3 major components here. Scale A, which is the outer scale. You can see it in the example here, it's marked in red, and it provides a way of inputting reference data with pointers. It's kind of like buttons on a calculator, and it's also where you'll read all the variables from, except for time. So one of the things that we'll keep referring to is distance is always on the outer scale, time is always on the inner scale, speed is always on the outer scale, time is always on the inner scale. So the inner scale, scale B, it's used to read time in minutes or seconds, and it's also used for conversions, multiplication, division. The list is long, and we'll cover a lot of those things in here. Scale C, which is not overly advertised, and certainly some of the documentation that I was reading when I was going into my Air Nav exam didn't really cover it off, and it's basically an hours scale compared to the minutes scale, or the inner scale. So it doesn't move. It's static, and anything on the inner circle, whether it be scale B or scale C, is always minutes or hours. So it's always time based. This just gives you a really quick reference point in if you're doing a calculation and it's minutes on the outside of that Wizz Wheel. You can then have a quick look at scale C and reference it to the minutes on scale B and find the hours. So for example, if you did a calculation and the answer was 70 minutes, you can then have a quick look and it's roughly 1 hour 10. And it becomes quite useful later on, especially from a time perspective. Saw what I did there. The pointers are the big thing here. They're the input method for the E6B. Different pointers will give you different outputs in different units or bases, and this is all it is. It's basically a 10 base, a 60 base, a 360 base, and it's just the method of calculations. So the multiplication and division pointer, this is the tiny pointer that extends from the center of the 10 on the inner scale, and it's sort of silver 10 digits on a black background. It's quite obvious. And the two that we really run here is the triangle, which is also the 60, and the square 10, which is the 10. When it's coming with multiplication and division, we're always going to reference the 10, not the 60. And it's really just the mathematical problems. So multiplication and division, always use this. And once you get used to it, it's very, very simple. The second pointer is the little pointer above the E in seconds, which allows you to work within the seconds lot of measurements. It lies on a 36 because there's 3,600 seconds in an hour. And again, you'll use that occasionally, but nowhere near as much as the minute and hour pointer. And that's the big triangle pointer. It's the most commonly used, and it allows you to work with minutes and hours or to do anything in base 60. So as long as you can remember that base 10 for the multiplication and division, obviously base 60 for hours, minutes, and seconds, because they all run in a base 60. So multiplication, it's one of the most common things that you're going to have to do in the exam. Get some practice around it, because once you've mastered the multiplication, then division becomes easy, and anything that you need to do on the fly in the exam around the questions you can do quite quickly. So I'll put an example up here. 9 times 9. As you can see, the multiplication and division pointer, the base 10, we're lining up with the first part of our question, which is what is 9 times something. Now once we've got that, we have the 9 times table basically surrounding. Now that that's aligned, we can read off anything. So we can see that 9 nines are 81. We can also see that 9 eights 72, and you can then work to this. So as long as you remember that your 10 base to the multiplication table that you're trying to work to, you can then read it off. So basically, as per the documentation, rotate the inner scale to place the number you want to multiply with over the 10. then find the number you want to multiply by on the inner scale and read the answer directly above that number on the outer scale. Simple. Repetition is going to be your friend here. So the more that you play with this, the better it's going to be. So to multiply 9 by 9, really easy, but you can do that in your head. So this was a great first problem to help you get used to the E6B. You will immediately notice that the E6B doesn't actually have a 9 on the outer or inner scale. It instead has numbers 10 to 99 on it. Now, one of the common features that we're going to see through all of these calculations is that they don't account for orders of magnitude. This works in your favour, but it also works against you. You have to be able to do some expectational arithmetic. What kind of number you want to be looking for. On the positive side, it means that any number on the scale can be represented in any order of magnitude of that number. So 90 in the example could be 9, 90, 900, or 9 million. On the negative side, it means that you have to know the expected order of magnitude of your answer. So 9 by 9, you know it's going to be sub 100, and so therefore you can kind of work it out. And we need to do this quite a lot. Conversely, if we're multiplying 90 by 90, we know that it's not going to be sub 100. So 8,100 will our answer be, and that should be what we're expecting. We will see this in these problems a lot of the time. So it's good to be able to have that sort of mental expectational arithmetic. And again, we do that on a constant basis when we're expecting change, or we're working out the rough amount of hours. So we know roughly what to expect, and we just need to lean on that because the orders of magnitude are not given. So a bigger problem, one that we can't really do in our head, is if we work out 22 times 35. So simply, we rotate the inner scale, our base 10, and we put that to what we want to multiply, what times table we want to use. So it's the 22 times table, and then we read off again on the inner scale 35, which is our multiplier. And we read out on the outer side of or our outer scale, and that gives us 77. Now it gives us 77, but we know that the answer isn't 77 because 22 by 35 has got to have it's got to be in the hundreds. So again, we can roughly expect sub 1,000. So 770 is our answer. So not in the thousands, not in the tens. This is the kind of arithmetic that we need to be able to do. So we've got some practice stuff that we can do later on. Now division is the same multiplication technique, but in reverse. So what we do is rotate the wheel to align our numerator on the outer scale with our denominator on the inner scale. And this time we read our answer from the base 10 pointer. So again, we've got a little example on the screen here. So we've aligned 15 divided by 3, or 30 in this particular case. So we've basically created a fraction, 15 over 30, and then we go over to our 10 base pointer, and we can see that the answer is 5. So always remember that when you're doing a division, you're basically creating a fraction, something over something else, and we even set that up on our scale. So outer scale is our top number, inner scale is our bottom number, and then we go over to our base 10 pointer and read off the answer. Really, really simple. So let's have a go at these problems. 60 divided by 25. Now the first thing we want to do is we turn that into a fraction, so 60 over 25, and we align those two pointers. And then once we've done that, rotate or move your vision around to find the 10 base pointer and read off the answer. So what you can do is quickly pause the video, go back, pause the video, do these calculations, and from there just make sure that you're working in the right orders of magnitude. Know what you're expecting. And once we get that done, you'll always get pretty much the on-par answer. The exam questions are geared in a way to try and make you fail. So you may get a question that gives you a calculation requiring you to divide 60 by 25. Your answers will be 2.4, 24, 240 or 0.24. So you've got to have that order of magnitude nailed. All right? You've got to know what to expect, because they're geared, that the entire answer subsets are geared there to make you fail. They will find ways to be able to trip you up every way. All right? So you've got to really get this nailed. But anyway, get some time, run it through, see how you get on. So taking the multiplication and division and actually giving that into an aviation-related problem. On a cross-country flight, you climb at 650 feet per minute for 7 minutes. Now you've got to work out how much altitude did you gain. Simply put, it is 650 feet per minute times the number of minutes, 7 minutes, gives us our ascent rate. So we can work out from there that 650 times 10 gives us our upper limit, 6,500 feet. We know it's not going to be more than that. And 6,500 times 5, you've then got to work out your base limit, and so now you know roughly where you're looking for your expected answer. Get into the habit of that, and again, you'll always get the right order of magnitude. So watch the order of magnitude each time and apply logic as necessary. Your Cessna probably gained more than 45.5 feet over the period of 7 minutes for 650 feet per minute. But it's not a jet engine, it's certainly not a rocket, so the chances of it getting up to 45,000 feet in 7 minutes is pretty slim. If not, would love to buy that Cessna from you. So you need to descend now, 5,000 feet in 7 minutes. What's the descent rate and what will you need to be able to derive this? So we know that we have 5,000 feet in 7 minutes. What's the process? What process are we going to work through to be able to give us a rough understanding of what that order of magnitude should be? And the slide rule will give you the rest of the answer. So roughly 715 feet per minute. And I say roughly because the Wizz Wheel can only handle 2 non-zero digits in its answer. So we do approximate, but again, we do roughly the same thing when we're trying to work out our order of magnitude. Just get used to that process. All right? Now the E6B can do other calculations and conversions. These are just like the really easy ones. Working out feet to meters and meters to feet. If you have a look at your Wizz Wheel now, you can see that there is a meters on the inner scale and there's a feet on the outer scale. Line the two up, and then you can work out if you want meters to feet, line up on the inner scale, find your number, and then your conversion will be on the outer scale. Vice versa, if you've got trying to work out what 16.4 feet is, align feet to meters, feet on the outer, meters on the inner, read from the outer, and the answer will be on the inner. Nautical miles and statute miles is actually quite cool in the way that they've given a small section to the E6B where, as long as you line up, if you've got a problem where you need to work out how many statute miles it is, align your the number that you do know under a given whether it be nautical or statute, and your answer will be on the corresponding pointer. Really simple. Works in the same way that you would see your Fahrenheit and Celsius conversions. You find on the outer, but all you're doing is you're lining up beforehand. The gallons to litres, you will get some quirky little questions where you need to be able to derive this, and that's because some of the older planes that we have still function in gallons, some of the newer stuff is in litres, or you've got to be able to work out burn rates. So you've got to be able to get your working knowledge into, or your working question into the same derivative. So if you're going to be working in gallons, get everything converted to gallons. If you're going to be working in litres, get everything into litres, and then do your equation. A lot of those exam questions will give you X amount of gallons, you're burning X amount of litres per hour, you've got X amount of gallons on board, you've got to work out your burn rate. Work out which one you want to work to, get everything on the same par, and then do your calculation. It takes a little bit longer, guaranteed you get the right results. Same as the nautical and statute miles, you'll need to be able to do that. Feet meters, exactly the same thing. So they are giving you questions in the exam to make you think through it rather than just mathematical equations. So we've got the other ones where miles to kilometres, when any value of a statute or nautical mile is set opposite the stat or naught index markers, the distance in kilometres will be read opposite the km index located on the outer scale. So get your number. If you've got to work out how many kilometres from a statute mile, get your Wizz Wheel, put 10 under stat, so that gives you 1, and you can see how many kilometres there are on a statute mile and vice versa. US gallons to imperial gallons, these do come up on the question. Again, you've got the indexes, work through it. Get your Wizz Wheel out now and have a quick look. You've got the US gallons, you've got the imperial gallons, just marry it all up. Most importantly, when converting from US gallons to imperial gallons, align the appropriate US gallon number under the US gal, and the corresponding volume in imperial gallons can be read under the imperial gal. So again, you just got to know where your pointers are, get used to where your pointers are. You can read them all the way around the outer scale, and you can work it out from there. When converting from imperial gallons to US gallons, align the appropriate imperial gallon number under the imp gal index. The corresponding volume in US gallons can be read under the US gal. So it's just important to know where these are and then how we quickly use them. Gallons to litres. Locate the US gal, imperial gal, and litre index marks. So when converting from US gal to imperial gal to litres, it's a 3-step process. Align the appropriate US gallons index or the imperial gallon, and then the corresponding volume in litres can be read under the litres. Nautical miles or statute miles, we've already done that. Really, really easy. When converting from statute mile to nautical mile, align the appropriates, we've done that. Pounds to kilograms, again, we can look at this as either fuel pounds, we can look at this as due to the viscosity, oil pounds, and all of these are very easily marked out, so it's important to get acquainted with those scales on the outer of the E6B. When converting from kilograms to pounds, align the appropriate kilogram number under the kg index. The corresponding weight in pounds can be read under the pounds. But make sure, because you've got a few different pounds that you need to do, so make sure you're using the right one for the right question. Feet to meters, again, we've covered that off, nice and easy. So what I've done in these is I've tried to limit these down, and I've removed the Q&A stuff now as a separate video. In order to just be able to do this. If you think it's a bad idea and you want to see the old Q&A stuff as a separate one again with just the questions and answers, drop me a comment, let me know, and I'll incorporate them back in. But please don't forget to like, subscribe and share. We generally aren't the only ones that ever go into these exams. So share them out, share the love, and hopefully we get more people through this. Alright, take care.